The forward and aft cargo compartments of the 777 are each equipped with a single smoke detection unit. Air in the cargo compartments is drawn through the detection units and analyzed by photoelectric smoke detectors. Both cargo compartments are protected from fires by 5 cargo fire bottles. When discharged, 2 of the bottles empty immediately and 3 of the bottles meter the extinguishing agent into the compartment. All fire bottle discharge squibs are automatically tested once each flight. Crew extinguishes cargo fires from the cargo fire panel located here on the overhead panel. This is how the panel appears during pre-flight. All warning lights are extinguished, and the cargo fire arm and discharge switches are off. Watch what happens when a cargo fire is detected. In addition to the master warning light and fire bell, when a cargo fire is detected, an ICAS warning message appears. The associated cargo fire warning light also illuminates. Push the aft cargo fire arm switch to arm the extinguishing system. The aft cargo fire arm switch accomplishes the following. First, it arms all fire bottle squibs plus the flow valve squib for the aft compartment. Second, various ventilation and recirculation fans are shut down, and the air conditioning packs are commanded to provide the minimum airflow required for pressurization. This reduces airflow in and around the compartment, prevents additional air from feeding the fire, and reduces extinguishing agent leakage from the compartment. It also shuts down the aft and bulk cargo heat systems. Use the cargo fire discharge switch to discharge the fire bottles. Pushing and holding the cargo fire discharge switch for 1 second immediately discharges the rapid dump bottles. When pressure is sensed in the discharge tubes, the cargo fire discharge light illuminates. It also activates the flow valve squib for the aft compartment. After the rapid dump bottles have discharged, the ICAS advisory message, Bottle Discharge Cargo, displays. The discharge switch also starts a 20-minute automatic timer, which is used for discharging the metered bottles. Metered bottles discharge depending on the condition of the airplane and the timer. If the airplane has not landed after 20 minutes, all 3 metered bottles discharge. The extinguishing agent is automatically metered into the selected compartment. The metering maintains a sufficient concentration of agent in the compartment over an extended period of time. Now, let's look at a second situation. If the airplane lands before the 20-minute delay is complete, one of the metered bottles discharges upon touchdown. Let's look at a final situation. If the airplane is on the ground when the discharge sequence begins, one metered bottle discharges after 20 minutes. Touch an item for review or touch the green arrow to continue. If the cargo fire occurs in flight, the landing altitude is set to a higher altitude. This increases the cabin altitude, which reduces differential pressure and reduces airflow around the cargo compartments. The pressurization is reset to auto prior to descent. Let's look at a fire in the forward cargo compartment. Arm the forward cargo fire extinguishing system. The forward cargo fire arm switch accomplishes many of the same functions as the aft switch. All fire bottle squibs and the forward flow valve squib arm. Ventilation and recirculation fans shut down, and packs provide minimum flow. In addition, the equipment cooling system automatically reconfigures to the override mode. Discharge the fire bottles. The discharge is directed to the forward compartment. If the other cargo fire arm switch is subsequently armed, the arming functions of that arm switch are accomplished. Since the discharge switch has already been pushed, the metered bottles are directed into the previously armed compartment. If either cargo fire arm switch has been armed, the system can be disarmed by deselecting the switch. Disarm the aft cargo compartment. Do not push both forward and aft cargo compartment arm switches prior to discharge. If both compartments are armed before discharge is initiated, the extinguishing agent is divided between the two compartments. This results in an insufficient concentration in both compartments. Next, we'll examine the Wheelwel fire detection system. The main gear Wheelwel contains a dual loop fire detection system for each main gear. Each dual loop system is automatically tested at power-up and continuously monitored thereafter for faults. The system can also be manually tested. High brake temperatures alone will not activate the fire warnings. The system is designed to sense only the excessive temperatures associated with the fire. An actual fire in the Wheelwel creates temperatures high enough to activate the fire detection system. In addition to the master warning light and fire bell, when a Wheelwel fire is detected, an ICAS warning message appears. There is no extinguishing system provided for the Wheelwel. Instead, first observe the extend speed limit and then extend the landing gear. This attempts to extinguish the fire and reduce temperatures in the wheel well. Extending the landing gear will also keep the gear away from the fire source if the wheel well is on fire. When the temperatures in the wheel well are below fire levels, the ICAS warning message is removed. Once extended, the gear should remain down and a landing made at the nearest suitable airport. If you must retract the gear for airplane performance, leave the gear extended for at least 20 minutes after the wheel well fire warning has extinguished. This ensures that the wheel well fire is extinguished. A single smoke detector is located in each lavatory. When smoke is detected, an oral alert sounds in the lavatory compartment, a light illuminates outside the lavatory, and the ICAS advisory message, Smoke Lavatory, is displayed. The lavatory fire extinguishing system consists of one heat-activated fire extinguishing bottle. Next, we'll look at a non-normal situation involving the cargo smoke detection system. Each smoke detection unit is automatically tested upon power-up and continuously monitored thereafter for faults. It can also be manually tested. This ICAS advisory message displays whenever a smoke detection unit fails. In this example, fire detection is not available for the forward cargo compartment. There are three conditions that cause a smoke detection unit to fail. To illustrate these conditions, let's take a closer look at smoke detection operation. Each smoke detection unit is equipped with identical and redundant components to reduce the chance of a failure. Air in the cargo compartment is drawn from 3 zones into the smoke detection unit. Each zone is analyzed separately for smoke by its own photoelectric smoke detector. Faults in 1 or 2 zones do not affect fire detection capability. Faults in all 3 zones constitute a failure of the smoke detection system for that compartment. Only one of the 2 identical control channels is needed for operation of the smoke detector unit. If faults are detected in both control channels, the unit has failed. Each unit has 2 fans, of which one is always active. If both fans fail, the detection unit is inoperative. This concludes the instruction section of this lesson.